Hello everyone, thank you for coming to join us. I know people are settling down but are running a little bit behind time, so respectful of time, I'd like to kick off. First of all, it would help me hugely, a quick show of hands, who is familiar with NGINX? Most of you, that's really encouraging. What I'd like to do today is to tell you a little bit about NGINX, explain what makes us qualified to talk about load balancing in clouds, and share with you some of the technologies and solutions that we're bringing to the community and to the market to help you make the most of our technology and the most of your investment, whether it's in OpenStack or OpenShift or Kubernetes or any of the other cloud virtualization or containerization platforms. We live in really, really interesting times. I was in Detroit a little while ago, I visited the Henry Ford Museum of Innovation, and there was lots of exhibits about industry in America around about the turn of the last century. And it was striking that in 1879, the light bulb was widely available. 1881, New York, London, and other municipalities had electricity generating services to take electricity to the home or to the industry, but it took a further 40 years for manufacturing to change and start really leveraging the disruptive potential of electricity. Before that, they were stuck in a hardware environment where factories were built around steam engines that drove shafts, and all the machinery danced to the tune of how the steam engine forced the factory to be architected. And it took 40 years for industrialists to re-platform their factories, to bring in micro-electric motors rather than the monolithic steam engine in order to realize the productivity benefits of electricity. Why is that relevant now? Well, the difference between now and then is that we no longer live in a world of hardware. We live in a world of software, which means that we can take these disruptive technologies, whether it's OpenStack, whether it's containerization technology, whether it's cloud technology, we can take those disruptive technologies and turn those into opportunities that we can leverage to innovate and build services faster. And what qualifies NGINX to talk to that? Well, many of the world's biggest disruptors are using IT to innovate and bring new services to market faster. Adobe are using NGINX at the core of their Photoshop online applications, converting Photoshop and other applications from being desktop apps to mobile apps, with NGINX as the API gateway for those mobile applications. Dropbox are one of the companies that are making your CIO irrelevant by creating fast, easy ways to share files so consumers can access the kind of enterprise services better than enterprises can provide themselves. And they use NGINX to build a high-performance edge cache to get content closer to users. BuzzFeed, disrupting journalism, they use NGINX to create a content switching platform so that they can deploy different versions of their web application in different geographies, and dynamically they can switch users from one version to another. So they can do things like A/B testing and canary releases. They seem to like New Zealand most of all. They push all their new application content out to New Zealand first, using NGINX and geolocation, and test it there before rolling it out worldwide. And all of these other companies are using NGINX to power the disruption in that they're creating in their industry. And that's just scratching the surface. NGINX, the web server and reverse proxy, powers more of the 1 million busiest websites in the world than any other piece of software, based on W3 Tech's figures. In fact, if you drill down and look at the 10,000 busiest sites, 62% of those are running in NGINX. Netcraft, another survey company, have surveyed over 1.5 million public NGINX servers, so NGINX servers directly connected to the internet, and have measured over 250 million websites running in NGINX. If you're planning to build a successful, busy website or web application, deliver it through our technology. And it's not just for public-facing, front-end load balancing and application delivery. Sumo Logic surveyed web servers running on AWS and found that 40% of those running on NGINX. DigitalOcean did the same. The DigitalOcean user base is more developer-focused, it's more forwards-looking than the Amazon user base. 65% of the web servers on DigitalOcean were NGINX. And NGINX is the top pulled and starred application from Docker Hub. So not only is NGINX a core bit of technology for the front of an application for north-south traffic, it's also a core bit of technology to be used inside an application as well. The world's key internet services are built on NGINX open source. Netflix, driving over a third of US internet traffic, runs entirely on NGINX. Load balancing services and CDN services like Amazon's CloudFront and load balancing services, CDNs like Cloudflare, MaxCDN, StackPath, and many others that confidentiality agreements mean that we can't share, they're all powered by NGINX. We have a rich body of partners who are working with us and building solutions on top of NGINX. In fact, even one of our lead sponsors here provides a load balancing solution that is built on NGINX, open source. So that gives us a unique perspective as we work with the community and enterprise customers as to how the industry is changing, the technologies people are adopting, and the challenges they're facing. And I'd like to give you 5 lessons that are coming through consistently from each of the users and customers that we talk with. First of all, cloud changes the architecture of your application, and there are significant consequences to that. Modern applications are made of smaller parts, they're composable, and they're portable. As you go through this transition, a transition both of going from a physical to a cloud data center, and at the same time going from a monolithic architecture to a microservice-like architecture, when you're doing that with a running application, you need to keep that application up. You need to keep it running. You need to be serving it consistently to the wide variety of different client applications that are accessing it. And lesson 1 is the key bit of technology you need to achieve that is some sort of reverse proxy. The reverse proxy is the front end to your application. It provides a consistent point of entry. It handles traffic in a consistent fashion from different client devices, and then it carries the intelligence and it makes the decisions about where that traffic should be routed to, how it should be transformed, what protocols it should be changed to, so that you're free to change the implementation of the application behind the scenes without affecting the perspective and the view that your end users have. So a really common use case for NGINX and other reverse proxies is to help organizations migrate and navigate through this change from physical to cloud, from monolith to microservices. So, lesson 1, applications change. Cloud changes the way your applications are architected. A reverse proxy hence helps insulate your users from that change. Lesson 2, this technology needs to be delivered as software, not hardware. Why? Because the complexity of this change and the loads that it puts on the reverse proxy in front means that your application team has to own that technology. They cannot afford to be funneling every single change through some sort of central load balancer device, whether it's owned by the network team or whether it's owned by some separate application silo. You need to build the entire application stack to be cloud agnostic, so that your application team, maybe you're using OpenStack in production, but nevertheless they still need to be able to spin it up in a dev environment on their laptop or on Amazon. So a software-only approach lets you do that. Software all the way down, it's infinitely pluggable. HashiCorp, at their recent event, put up, I think, the best slide that illustrates what has changed in the world. The OSI reference model is no longer layers and layers and layers of physical levels. It's software all the way down to a point where the physical part really does not matter. Some of you may be in a situation where you're working in an environment where there is a legacy infrastructure team who are responsible for the hardware load balancing that fronts your application. And you'll know that that style of load balancing is falling out of favor. It's becoming irrelevant. It's being boiled down to essentially what Amazon provide with ELB, or other cloud providers provide with load balancing as a service. And you may find that those teams are furiously defensive of their technologies. As disruption happens, changes like that have to be navigated. I can see a few people smiling. You recognize that situation. Hardware load balancers are the last bastion of what was the dot-com era of buying everything in big iron. You'll hear the hardware team talking about the need for hardware load balancers as the only way to meet your SSL performance requirements, the only way to achieve the requirement and the resilience that you need. Google would dare to disagree. SSL accounts for less than 1% of their CPU overhead on their front-end servers. Facebook would concur with that. Software-based TLS implementations on commodity CPUs are fast enough. If that's good enough for Google and Facebook, perhaps it's good enough for your team as well. Don't be afraid of spurious performance claims. And let me just finish by pointing out that that Google statement dates from 2010. The Facebook statement dates from 2012. 7 years old, 5 years old. These large enterprise and infrastructure companies were finding that there was no longer a need for hardware acceleration for web applications. Lesson 3. You need a lot more than just load balancing to deliver an application. The holy grail of an application developer is that they can build the functionality that your business needs using the stack and the technology of their choice without having to worry about the messy operational tasks of delivering and running this thing in production. And you want to take all these messy operational tasks and converge them together onto a platform that will help you deliver that application that your development team has written. And those tasks go far beyond just load balancing. They cover acceleration, they cover caching, front-end authentication, optimization of protocols, DDoS protection, application firewalls, monitoring, high availability. So if you just limit yourself to thinking about load balancing, you're missing a lot of the picture. In order for your application to be successful and to run in this multi-cloud environment, you need to bring all of that technology together into a single converged solution that you can give to your application team, and they can leverage and they can tune for their particular application, and they can deploy with the application, whether it's on their laptop in a dev environment or it's on OpenStack in their production environment. Lesson 4. You might think that load balancing is just something you do at the edge of the data center. And the application running behind that load balancer is running within the data center is subservient to that load balancer. The world's moved on a long way since that approach. Understand where you need to deploy this converged capability of load balancing and application delivery. If you think that load balancing is a centralized service managed by a single team, you're only seeing half the picture. That might be the case for the data center load balancer, but again, and we say it again and again and again, it's about democratization. It's about providing the application team with the right technology so they can build and test their application in a production identical environment. And think about how load balancing can help you build and scale and enhance the application. Come and talk to us and we'll share with you what we've done with straightforward proxy approaches, embedding load balancers within applications in a kind of an ESB fashion to handle the communication in a microservices-like architecture, or taking it to its limits, putting a load balancer with every single application instance in what's sometimes called a sidecar model. So each microservice and application component has their own local load balancer to orchestrate and manage and route traffic as it talks to other services. And lesson 5, as I've alluded to, build application delivery directly into your CI/CD pipeline. Centralizing it is wrong. Automate everything. With DevOps, allow your application team full access to all of this technology. So, conscious of time, I'm going to rush through and talk about some of the things now that NGINX can do to help you realize some of these benefits, and talk about some of the things we've learned working with our customers and our users. How can NGINX help you? So I've talked about NGINX open source, the industry-defining open source web server, reverse proxy, web accelerator, not only a standalone project, but at the core of a lot of technology that supports key internet services. We also provide a number of other products that are built on our experience and our knowledge with NGINX open source. And our strategy as we build out these products is to take what can we learn from the early adopters of new approaches, new technologies, new design patterns, and how can we fold that back into our product roadmap so that we can give you the learnings and the experiences of the early adopters in an easy-to-use open source or commercial software package. NGINX open source, of course, is the core of everything that we do. We are fundamentally an open source company. We work heavily with the open source community, with the benefits and some of the challenges that brings. NGINX Plus is our enterprise-ready commercial build of NGINX open source. And it really embodies the design philosophy that I talked about, taking what early adopters and pioneers are doing and converging that into a single software package that gives you advanced load balancing, health check, session persistence. It gives you full control over content caching. It includes all the core capabilities from NGINX open source and extends those with security controls, capabilities like mod security for a web application firewall, and monitoring and management technology. Rich stats, rich dashboard, rich APIs to manage it. In the cloud, the killer features for NGINX Plus that you would not find in open source are things like the health checks, so that we can dynamically detect, proactively find failed servers, alert, and route away from them. The rich extended status. There's a powerful API that you can use to pull a host of metrics out of NGINX Plus that aren't available in the open source project. And integration with service discovery through DNS or through an API, so that when you change the back-end architecture of your application, the front end or internal load balancer will automatically detect that and reconfigure without a costly and disruptive rewrite and reload of the configuration from disk. But there's a host of other initiatives that we do at NGINX as part of our open source community. Mod security. We work proactively with TrustWave on the mod security project. We contribute code. We've helped them create an NGINX tuned version of mod security, which is available as an open source release for you to build and deploy yourselves, or which we provide as a pre-compiled, pre-tested binary with full support. On Kubernetes, we've been running a project to create an ingress controller implementation for Kubernetes. And just a few weeks ago, we announced that that is now a fully supported NGINX project. If you take NGINX Plus and deploy that in Kubernetes, you can run it in an ingress controller mode with our open source ingress controller. At the same time, you can take NGINX open source, spin it up with the ingress controller, and go ahead without needing to work with us. Recently joined the Cloud Native Compute Foundation, specifically with the goal of working with a new project called Istio that's doing some really exciting things around service meshes, building a mesh architecture for networking running on top of Kubernetes to allow microservice applications to autonomously connect to each other and broker transactions. We're working with the Istio project to create the right tooling so that NGINX can be embedded as the sidecar load balancer within each of the individual microservice instances. And on top of that, we have a number of projects with Ansible, OpenShift, projects to build router implementations and be part of a catalog. You'll find integrations that NGINX are sponsoring or creating with tools like Etcetradine, Council, and Zookeeper. There is a very, very rich ecosystem of technology that surrounds NGINX and allows you to leverage it in whatever environment you select. Of course, none of this is much use if you can't monitor it, see what's going on. Amplify is our SaaS-based monitoring tool. It allows you, it gives you, starting from a free tier, you can sign up and start monitoring NGINX right now. Gives you out-of-the-box graphs for NGINX metrics, for operating system metrics. We're building out integration to monitor things like PHP, FPM. Gives you details on the system and application performance that you can start from an overview page to get a high-level view of the health of your application, do regression analysis between different periods of time to determine what has changed, what are the effects. Drill down with a range of custom graphs, hundreds, almost thousands of different metrics can be pulled out of an NGINX environment from both NGINX open source, the extended status from NGINX Plus, analysis of log files, access and error log files, so that you can build reports and graphs that drill down, even down to an individual URL and an individual method. And what I love most of all about Amplify is the configuration analysis tool. It gives you deep insight into the configuration you've written for NGINX and builds on our knowledge to identify classic and common mistakes with NGINX configuration. Errors in SSL configuration, missing particular proxying and load balancing configurations, suggestions about optimizing rewrites, locations, security measures. And the great thing about Amplify is it is a SaaS-based product and it starts with a free tier so you can get started immediately. If you need to scale beyond a certain level, we have commercial tiers that then will work with you and provide full support on that. But as we wrap, what have we learned from our experiences of helping customers build solutions that load balance applications in clouds? In summary, we've gone a long way with NGINX, the reverse proxy. With building out NGINX Plus, we've created a very, very effective, widely used, widely adopted technology for delivering applications, whether they're in a physical data center, a cloud data center, they're monoliths, they're microservices. But as we look forwards, we can see there's much, much more that we can do with the technology and expertise we have to help you build high-performance, highly available applications running in any infrastructure, the infrastructure of your choice. The reverse proxy alone is not a sufficient solution for that. I'd like to share with you a couple of new product announcements coming from the NGINX team. The first is NGINX Unit, the building block for modern applications. This is a new open source application server platform from NGINX that addresses some of the challenges of building microservice applications. The challenge of having to maintain multiple different stacks for multiple different languages. Unit provides a single stack that supports multiple language runtimes, and we'll be extending this outwards in the direction of Java and Node throughout this year and the next. The challenge of building something which is responsive and can adapt to changes in the application infrastructure. Most application stacks have a fairly legacy approach with our configuration file driven, and making updates and changing them on the fly is disruptive, which is one of the reasons why it led Docker to espouse an immutable infrastructure approach, where rather than reconfiguring your stuff, you throw it away and redeploy it. We think that's wasteful. It causes errors, it causes a greater risk of downtime. So Unit is entirely API driven and entirely on the fly reconfigurable. And further down the line, building in load balancing technology so that Unit instances can detect and find each other and create a service mesh so that you can deploy your application in multiple components and Unit will network it for you. Unit was announced a couple of weeks ago. It's available as an open source project. You can find us on GitHub. You can get started. Huge amount of interest. Really, really exciting next step for NGINX. And our controller project. Creating all this great technology is great, but you want a way to manage and control it and to use it to its greatest effect. You want to be able to define the policies for your application. And this is the goal for controller. Policy control, automation of DevOps-like workflows for your applications, whatever the environment. This is part of a journey with NGINX. It's the next phase of our product development. It's a really exciting time. And for those of you who adopt NGINX technology, we'd love to have you as part of this journey. Taking NGINX right now and using it as the front-end load balancer and application delivery controller for your application. Using NGINX and, when time comes, using Unit as the platform for running and delivering large monolithic applications. In the future, as you go through a transition, then NGINX will smooth that transition from a monolithic approach to a distributed microservice, service mesh-powered approach. Controller on top, providing the benevolent God's eye view to help you orchestrate and control this application platform, running across multiple clouds, multiple technologies, containers, and bare metal. This is the vision that we have as NGINX, the open source company. And if you'd like to find out more, I'd love to talk with you. We have a table at the back. I'm respectful of time. I know we're running a little bit over, so I want to thank you for your time now. I'll take some questions very, very quickly, but apologies if we cut it off short. So thank you again for your attention. It's been great sharing some of this information with you.